All right, so here is the next section. We have this one and one more, so you're getting super close to being done. This section is about rational equations. So the last unit was all about finding different features of rational functions. This one specifically, we're going to talk about how to solve rational equations. And so if you kind of look on the page, you can already kind of see them, what rational equations look like. But remember, a rational function is a polynomial over a polynomial. Technically, you could consider this rational function because a line is a polynomial. And so what you do is you have some kind of operation between some functions, maybe equal to a rational function as well. And so our goal is to figure out what value of x makes this equation true. Before we start, though, there's one thing that we need to note for all of these problems. And you first have to check out what would make the denominator equal to 0. So because you have an x in this denominator and an x in this denominator, if x equals 0, what's going to happen? This would be 3 divided by 0, and this would be negative 1 divided by 0. And you're not allowed to divide by 0. Like that rule, it still applies. So one note, as we solve this, you cannot get 0 at the end. If you get a 0 at the end, that means it's what we call an extraneous solution, and it is not an actual solution here. So just be careful as you're working through these that you pay attention to what would make your original equation make it divide by 0. So here's how this is going to work. We have fractions, and a lot of times we see fractions and we freak out and we're like, oh my goodness, I hate fractions. But the key here and kind of the strategy is to get all of these fractions to have the same denominator. So if you can get a common denominator amongst your fractions, you can get rid of every denominator and just work with the numerators. So this that has just an x, if it also has a 2 with it, then we're kind of on the start of getting them to be the same. So what you can do is you can times this fraction by 2 on the bottom, and it also means you can times the top by 2. And so this denominator would be 2x. With this fraction, to get it to be 2x, you can times it by x on the top and on the bottom. Now this fraction also has a 2x. So you could add these together and put them into one fraction, or we could wait and get this last fraction to be over 2x. So you would have to times this by 2. And then now all of our denominators are the same. And so if you think about an equation, if you divide, which is what a fraction is, every single term by the same value, the same thing, you're not actually going to change your equation. So because we have them all set up to be the same, you can get rid of them. And when you do that, you're just going to go with what's in the numerator. So in your numerator, you have 2 times x minus 1. So that's 2x minus 2. I'm just going to distribute right now. Plus, you still have this symbol here, plus 5x equals 2 times 3, which is 6. And you can go ahead and solve this equation, and the solution to this equation will be the solution to the original rational equation. So combining like terms, I have 7x equals, and then moving that over, I'll have equals to 8. So x would be 8 over 7. And that is going to be a solution. We don't have to check it as long as it didn't make the denominator equal to 0, which we said only happened at 0. So this is the solution, and it is the solution to that specific equation. All right, these can get slightly more complicated in terms of making the denominators a little bit more interesting. So here you have an m squared minus 64. Here you have an m minus 8 and an m plus 8. And hopefully you recognize m squared minus 64 as a difference of squares. M plus 8 and m minus 8. And so instead of thinking about it as m squared minus 64, think about it as its factors. And this one right here already has the m minus 8. And this one right here already has the m plus 8. So if you multiply this one by the m plus 8 and you multiply this one by the m minus 8, that will get them all to be the same. And so this factor right here, this one, will be times by m plus 8 on the top and on the bottom. And then this factor right here gets multiplied by m minus 8 on both the top and the bottom. And what that means is that the first one, m plus 8, m minus 8. The second one, m minus 8, m plus 8, which is the same thing. And the last one, m plus 8, m minus 8. So all the denominators are the same now, and they will all go away, leaving us with what's left in the numerator. So on this factor, we had 4m. This one, we have a 3m and a 24. I'm going to go ahead and distribute that. It is a positive 3 being distributed. And then this is 1 times both of those, so that's just m minus 8. And you're going to solve this equation. So we'll have 7m plus 24 equals m minus 8. I'm going to move my m's over here. So 6m equals, and I'll move that one over there, negative 32. So m is negative 32 over 6, which does simplify. They both have a 2. So negative 16 over 3. And then last but not least, you have to think about what made your original denominators equal to 0. So I know we didn't write it down at the beginning. We should have, sorry. So a little note, what can m not be? Well, for this one, m minus 8, it means it can't be a positive 8. For m plus 8, it means it can't be a negative 8. And for this 64, the m squared minus 64, since that was m plus 8 and m minus 8, it still can't be negative 8 or positive 8. So as long as it's not 8 or negative 8, then it is a solution. So the right answer is negative 16 over 3. All right, up next, we have an x minus 9 and x minus 7, and then we have a quadratic. So it's in your best interest to go ahead and factor this quadratic. Two numbers that multiply to be 63 add up to be 16. That is 9 and 7, and they're both negative. So we're going to think about that denominator as x minus 9, x minus 7. So before we start, I'm going to remember this time. Before we start, let's make a note of what x cannot be. It cannot be 9. It cannot be 7. Cannot be 9, cannot be 7. So x cannot be 9 or 7. If the answer is 9 or 7, then that's out. It won't work because it'll cause a divide by 0, and it'll be what we call extraneous. All right, so the common denominator is an x minus 9 and an x minus 7. So this already has both of them. So this first one needs an x minus 7. And so that'll also go on the top, and then those two will match. This one here needs an x minus 9, and that'll go on the top, and those will also match now. And now all three match, and when all three match, they're all going to simplify themselves out. And then you can just work with the numerators. So we'll have x times x minus 7, so that'll be an x squared minus 7x. We have a plus 3 times x minus 9, so plus 3x minus 27 equals, and we didn't have to multiply this one because it already had both of the pieces that we needed, 12x minus 90. All right, I'm going to solve this equation. Because there's an x squared, I'm going to either have to factor or use the quadratic formula. So I'm going to move everything over and set it equal to 0. So we'll have x squared minus 4x and then minus 12x, so minus 16x. And negative 27, and then we'll add the 90. So that'll be a positive 63 equal to 0. It does factor two numbers that multiply to be 63 and add up to be 16. That's 9 and 7, and they both need to be negatives. So the solutions, x equals 9 and x equals 7. And here, that should jump out to you. Really, from here, it might have jumped out to you that, hey, we said at the beginning it cannot be 9 and it cannot be 7. So both of these solutions are out because both of these solutions would make denominators equal to 0. And those are what we call extraneous. We didn't do anything wrong. Sometimes people think we did something wrong. We didn't mess up the math. What happened was as you're doing it, the only numbers that would make these equations true would cause divide by zeros to happen. And so really there's no solutions here is what's happening. The math implies that there's two, but really they're not because they would cause divide by zero. So no solutions. So it is possible to get some of these equations to have no solutions going on. All right, we're going to still solve some rational functions, but we're going to kind of transition what these rational functions look like. And they're going to have some variables now. And what we're going to do with the variables is we're going to solve for a specific variable. So this first one is I equals V over capital R plus little r. And we want to solve specifically for the little r. And so we're just leaving everything in terms of variables and trying to get this little r by itself. The first problem here is that it's in a denominator. And so what we can do is we can say, all right, I'm going to make this have the same denominator as this one. And I can do that as long as I multiply it on the top. And then what will happen is the denominators will go away. So essentially what you're doing is you're taking this one denominator and multiplying it over. Notice that there wasn't a bunch of fractions like the last few problems that we did. It was only one fraction. So if you have just one fraction, you can multiply it up. So we're going to have r plus little r times capital I equals capital V. And then there's actually two ways to solve for little r. The first thing you could do is you could distribute the capital I, or you could recognize, hey, I just need to get the I over to the other side, and it's currently being multiplied. This is something times I, so you can divide by I and move it over. You could also distribute, and you should be able to get to the answer as well. It will look different than our answer, but the computer knows to recognize both versions. Last but not least here, to get little r by itself, you have to move over capital R. It's currently being added, so you would subtract minus capital R. So little r is going to be equal to V over capital I minus capital R. Make sure when you type them in that you put capitals and not lowercase, because that will mess it up. It will probably recognize it as wrong. That is a capital V at the beginning, so make sure you put capital V. All right, we're going to do a couple more like this. They can be kind of tricky, and then we'll have some story problems to solve as well. So solve the equation for U. So for this one, this is going to be more, it's going to be similar to the ones we were just doing in terms of the fact that we have a fraction, a fraction, and a fraction. And if I get them all with the same denominator, then I can get rid of all the denominators. And so I want them all to have a P, all to have a U, and all to have a K. And so this first one, it doesn't have the U or the K. So I'm going to multiply by UK. And on the top, I'm also going to multiply by UK. The middle one is missing the P and the K, the other two. So I'm going to multiply by PK and also multiply the top by PK. And then this last one is missing the P and the U, so I'm going to multiply PU and the top also by PU. And all those denominators are now the same, which means they will all simplify themselves out. So the numerator is 7UK minus 6PK plus 8PU. And our goal here, our ultimate goal, is to solve for U. And if you look at this equation that we have right now, we actually have two U's in it. So the strategy here is if you ever are solving for a variable and you have multiples of them, you're going to want to move them to the same side. So I'm going to move this 8PU over to the other side by subtracting it since it's a positive term. And then the strategy here, once you have them on the same side, is to factor out a U. Because both terms have what we call a greatest common factor. They have a U in common. So take the U out, 7K minus 8P. And then that's still equal to 6pk. And then the final step is u times something, and you can get rid of the times by something by dividing. So it'll be 6pk divided by 7k minus 8p. We did this strategy of factoring out a variable when we were talking about inverse functions as well. So it's just a useful strategy if you're trying to solve for a specific variable and you end up with multiples of them. So you have multiple u's in your equation here. So put them on the same side, factor them out. All right, so here's another equation we're going to solve for p. Once again, there's two p's. Right now, my focus is to get rid of these denominators. I can get rid of them if they have the same denominator. One thing to know, a lot of times people think you can do this. You can add u and add u. You're not allowed to add to the top and bottom. You have to multiply the top and the bottom. So unfortunately, you can't just say plus u, and then get rid of all the denominators and go from there. By the way, if you did that, you wouldn't have any p's left anyways. But that's not a valid operation. So instead, you want to get the denominators to be the same so you could get rid of them. Another approach for this specific problem, the way it's set up, is you have a fraction equal to a fraction. So another thing you could do is also cross multiply here. That's an option as well. I'm not going to cross multiply. I'm going to go ahead and get the denominators the same. Because that's just the strategy that we've been using for all of them. So I want you to see that strategy so you don't think that there's like 8 different strategies for all these questions. So in order to get the denominators the same, this p plus u needs a p, and it needs to be times by p. So the top would be pe, and the p over here needs to be times by p plus u, so the other one would be p plus u. And then those denominators would be the same, so you can get rid of them. So we have PE equals F times P plus U. And that's what you would have gotten if you had just cross-multiplied from the get-go. All right, I have 2 P's. I'm trying to solve for P, so the strategy is to get to the P's all on the same side. Before I can move this P over, I actually have to distribute the F. So I have PE, FP, and you can write FU if you want. I'm just going to say UF so that y'all don't laugh the whole time. All right, now I have 2 P's, opposite sides, so I'm going to move this one over. PE minus FP equals UF. And those 2 P's, we can factor out P. That's the strategy here. So it would be a P times E minus F equals UF. And then last but not least, since this is multiplication, P times E minus F, you can divide UF over E minus F. So solving for P, you would have this set up right here. All right, looks like we have one more that we need to solve for a specific variable, and then we're ready to go ahead and get into some story problems. So solve for x. All right, once again, I have 2 x's, so I know I'm going to have to do that whole thing where I'm going to end up factoring out an x. In order to do this, though, I need to get the x's out of the denominator. And so what you can do is you can say, all right, I'm going to make this one have the same denominator. Right now, there's just a 1 in there, so I'm just going to times that by 7x minus 2. And on the top, 7x minus 2. And those denominators will be the same, so they will go away. So we have 7x minus 2 in parentheses times y equals 6x plus 7. This one specifically, since it was just y equals a fraction, you could have just multiplied the denominator up. 7x minus 2 just multiplied up and you would get this as well. So that's a strategy as well. But once again, I don't want you to think that there's like 8 different strategies here that you have to know. You can know, as long as you know that they have the same denominators, you can get rid of them. That's going to help. You can use that for every problem. All right, so x on this side, x on this side, I have to solve for x. So we're going to do that process of distributing the y first. moving the x's to the same side of the equal sign. Also, when I do that, I want to move the y term to the other side. I want to get it out of the way. So I just added 2y over here. I essentially flip-flop these. And then now that I have the x's on the same side, and there's 2 of them, we're going to factor out the x. That's the strategy there. So x, and then 7y minus 6, 2y plus 7, and do the division. All over 7y minus 6. There we go. We are officially solved for x. All right, so we are moving on to some of the story problems here. It looks like there's 7-ish slides for us to finish. These are hopefully going to be some good examples for you as you work through the ones in my Open Math. I tried to pull some questions from kind of across the board and where I saw a lot of issues in the past. So you could see these examples. All right, so the first one has a ridiculous amount of words in it. But at the end of this, it's really not that bad of an actual equation to solve. You just really have to siphon through all of this mess, right? There's just a ton of stuff. So it says the Doppler effect causes a sound moving towards you to sound higher pitched than the sound moving away from you, and the sound moving away to be lower pitched. So this is like when you have an ambulance or whatever. So as the ambulance gets closer to you, you know how the sirens get louder, and then as it passes you, it starts to diminish and go away. And so that's really kind of what they're talking about in this thing. There is a formula that they give us, which is going to be super, super helpful. And then what they do here is list literally what all of the variables stand for. So F is the observed frequency, C is the speed of sound, miles per hour. By the way, it tells us the number 761. V is the speed of the sound source. F sub O, that's just another variable because I already used F. Frequency of the sounds when stationary. So here's where we get all of the data, the information. So using a spectrum analyzer, we can determine the observed frequency when the car was driving towards us at 271 hertz. They said that's the observed frequency. So observed frequency is F, so we can label that. That is the F value. And the frequency while driving away was 243 hertz. And so the driving away is when the source of the sound is moving away from the observer, the equation that describes this phenomenon is, okay, so actually this is F and this is F sub O. Okay, no, I have these backwards again. Let's go ahead. I'm going to cross those off and try to re-figure out. So it says the source of the sound moving away from the observer. So this is the moving away from the observer is F equals, right? So F is the observed frequency of the sound in hertz, but this is the moving away portion. And we get that from this sentence up here. So it says the car is driving towards us at this hertz, and none of this has anything to do with moving towards. So we're actually not going to use that number at all. And the frequency while driving away is this one. So this is the actual F here. Suggesting the stationary frequency, and that's F sub 0. That's the stationary one. So this is F sub 0. So they gave us extra information here, and it's really easy to get fooled by it, right? Like I was like, oh, well, this is a number. It has to be something up here. And so you really kind of had to get into the nitty-gritty of what was going on there. So then it says use this information in the equation to estimate the speed. And when they say speed, they're saying the speed of the car. So that's V. So what we're trying to find is V. So we're going to use this equation. We're going to use F here, F sub 0 here. And they did tell us C in the equation here, and so we're going to use that to find the speed. So F is 243. C is the speed of sound, 761. And then their speed again, 761 of sound. Plus V, V is what we're trying to find, 257. All right, so here's your equation that we are trying to work with. And there's lots of approaches to solve this equation for V, so I'm just going to take one approach. The first thing that I see here is I see something times something, right? So your two options is you could go ahead and multiply this in up here, or you could divide this over. It's really up to you. I'm just going to go ahead and multiply it in the numerator right now. So if you do 761 times 256, I end up with this number. All right, so then from there, we have a fraction equal to a number, and we've solved this before. Remember, as long as you get a denominator over here to match, then you're okay. So what you can do is you can say, all right, we want this denominator to be this, so we have to multiply by the same thing in the numerator. And what's going to happen there is your denominators are the same, and so it's just a distribute, and then you can go ahead and solve. So 761 times 243, that's 1849.23, plus 243V, just the distribute here, equals the 1955.77 number. And then from there, you're probably good to solve this equation, right? You would subtract this over and then divide by that number. So the hardest part is getting to here. And really, I think one of the hardest parts is putting those numbers in those right spots. So I'm going to go ahead and finish calculating this. So 1955.77 minus the 1849.23. And then that number will be divided by 243. And that gives me a grand total of the V being 43 point, round your answer to one decimal place. So 0.8, and the units on velocity is in miles per hour. And that says it right here on that line, V in miles per hour. So literally trying to work your way through and pick out what numbers are supposed to go where, all that fun stuff. If you want, if you're doing a question similar to this and you want me to check that you have everything set up in the right spot before you go ahead and solve, I will definitely do that for you tomorrow or when you're working on these homework problems. All right, here's another one. This one is slightly easier to manage your way through. So it says one inlet pipe can fill an empty pool in 9 hours, and a drain can empty the pool in 12 hours. How long will it take the pipe to fill the pool if the drain is left open? And then it says use T as your variable to represent the time it takes to fill the pool. Write an equation using the information provided that can be used to solve this problem. Your equation must include 9 and 12. Which hopefully that's obvious because that's literally the only two numbers that they gave us. So this is what we call a work problem. And typically we talk about like working together, like if you have one person and then you have another person and then they decide to do the task together, what's happening there. This is kind of like you have somebody filling and then something emptying, and so they're working against each other. So here's how this is going to work. It's 1 over the time going in to fill the pool minus 1 over emptying the pool. And it's a minus because you're emptying it, right? The water level is going down. Is 1 over the time it will take for the pool to fill up. because it is filling up faster than it is emptying. All right, so if you're working through this, you just need to get a common denominator here. And so your common denominator will be T. For this, you need a T, and you also need a 12. I don't know why I wrote it like that. So I'm just going to times it by 12T. And then that will be the same if I do the same things here. So times by 12T. This one times by 9 and times by T, and then that will get that to be a common denominator. And then the last one, if you times it by 12 and 9, 12 times 9 is 108. So times that by 108. So we're going to have all the denominators be the same, so they'll all simplify. So we'll have 12T on the first one minus 9T on the second one equals 108. 12 minus 9 is 3. So 3T is 108. So 108 divided by 3 is 36. So it's going to take 36 hours for this to happen. So your equation was 1 over 9 minus 1 over 12 equals 1 over T, 36 hours. All right, next one. We have Hannah painting a room. 12 hours. Destiny can paint the same room in 20 hours. How long does it take for them to paint the room if they are working together? So it's going to be the same general setup as our last question, 1 over 12, and then 1 over 20. But instead of a subtract, because they're not working against each other, they're working together, we're going to add those. And that's going to be equal to 1 over the time that it takes for them to work together. So we're going to solve it the exact same way. The 12, you need to multiply it by 20 and T. The 20, multiply it by 12T. And the T, multiply it by 20 times 12, which is 240. And that will make all your denominators the same. So remember, you multiply the numerators by the same thing you multiplied on the denominator. All right, so they're all the same, so they will simplify themselves out. So you have 20T plus 12T equals 240. Those two you can put together. That's 32T equals 240. And then do the division. 240 divided by 32 is 7.5 hours. So if they work together, it takes them 7.5 hours. All right, so here is the next one. We have a plane can fly at 980 miles. In the same time, it takes a car to go 210 miles. If the car travels 110 miles slower than the plane, find the speed of the plane. So something important that you need to know is that distance equals the rate times the time, right? Distance is rate times time. And in this case, they are able to go different distances, but we're talking in the same amount of time. And so what we are going to do is we're going to solve this equation for T real fast. So T would be equal to the distance over the rate. And so we're going to have two setups here. We're going to have one for the plane, and then we're going to have one for the car. And we're going to know that these two are going to be equal because they happen in the same amount of time. So for the plane, the time that it takes, it can go distance, 980 miles, over its rate. And it doesn't tell us its rate. It just says the car travels slower than the plane, and it tells us the rate slower. So I'm just going to label this as R. The car, in the same amount of time, so these T's are exactly the same, is going to go 210 miles. That's its distance. But it travels slower, so it's going to be the same rate as the plane, but it's 110 miles per hour slower. So R minus 110. And because it's happening in the same amount of time, I can set these two equations equal to each other. So 190, I don't even know where I got that from, 980 R equals 210 over R minus 110. And this is the equation that you will solve. All right, once again, if you recognize it, you can just cross multiply, or you can get common denominators. So like this denominator over here needs an r, so times by r on the top of the bottom. This denominator over here would need an r minus 110, so you would times that on the top and the bottom, which is going to make the denominators the same, so you can get rid of them. Notice that that is just cross multiply, right? Like this one gets multiplied by that, this one gets multiplied by that one, and that's how the denominators go away. All right, solving this equation, I'm going to distribute minus times 110. So minus 1,800. That's going to be equal to 210R. All right, and then solving here, I'm going to go ahead and subtract this 980R to the other side. So I'm going to have this number still over here. 210 minus 980, negative 770R. And then you can do the division. Glad that both numbers are negative. I'd be a little concerned if they weren't. Only one positive, one negative. We get 140. And this is a rate, so this is how fast the speed of the plane is, how fast the plane is traveling, and it's going in miles per hour. And that's a realistic number there. So at the end, the nice thing is you can always kind of check and be like, hey, realistic, yes, that the plane could potentially travel 140 miles per hour. You could actually say what the car is traveling too. If it's 110 miles per hour less than that, it would actually only be going 30. So the car's not going very, very fast. So this is quite a bit of time that is happening here. All right. Getting closer, we're going to talk about some variation. And so we have directly proportional or direct variation. Means that y and x, there's just some number being multiplied. So y equals k times x. If they're inversely proportional, or some people might say indirectly, then instead of it being some number times x, it's some number divided by x, which is why this is in this section, because of this rational function equation happening. And then there's another one, varying jointly. And varying jointly is when you have three variables, x, y, and z, and that's going to be x times y with some kind of constant in there times z. The k, the constant in each of these, is called the constant of proportionality. So if it ever says find the constant of proportionality, it's saying find the k value. All right. And this makes it look a lot more complicated than what you'll probably notice as we go through these. So the first question here says, suppose that y is directly proportional to x. So directly proportional, if you go back, means that y equals k times x. So the relationship between x and y is that x times some number is y. So it says find the constant of proportionality k. If y equals 82.6 and x is 14. So literally, you're going to plug in that for y. We're looking for k, and x is 14. So all you're going to do is divide. So 82.6 divided by 14 is 5.9. So the relationship here is that y is equal to 5.9 times x. Oh, and I answered my next question. Using the k from above, write the variation equation in terms of x. Well, y is equal to 5.9 times x. That's the k value. So using the k from above, so using that 5.9, find y if x is 25. Well, y would be 5.9 times 25, which is 147.5. And then it says, if needed, round your answer to 3 decimal places. We didn't need to. So we're good. So that's an example of, that's an example of directly proportional. All right, the last example here that we're going to do says, suppose z varies inverse proportional with t. So what that means is that z is equal to some k, some constant, over t. So this is an inverse relationship. Instead of k times t, it's k divided by t. All right, and it says z is 20, t is 8. So when they give you 20 and the 8, you can find k. So 20 equals k over 8. So how do you do this? Well, you can just multiply by 8. So k is 160. It says, what is the value of z when t is 5? So what that means is you can now take this equation. Z is going to be equal to 160 over the t value. And so it says, what is z? What does z equal when t is 5? So it'd be 160 divided by 5. And 160 divided by 5 is 32. So z is equal to 32. So like I said, hopefully those aren't too complicated. It's just kind of a new relationship there between directly proportional, inversely proportional. This would be some good information to have as well, because you're not going to do a ton of examples, so it might not be something that you remember off the top of your head. Let me know what I can do to help you with the homework questions in My Up in Math, and good luck.